Our speaker today, Jim Young, is no stranger to the Ethical Culture Society. In fact, Jim has been a key player in every effort to grow and sustain the Ethical Society since he joined our community in 1983. Look out of the windows on the side of the building and you'll see very sturdy steel braces on the roof beams that hold this building up. That was Jim's first project, among many. Today's address is titled, Follow the Physics, Understanding the Future of Renewable Energy. Please welcome Jim to the podium.
Thank you, Lily. Good morning. About a year and a half ago, I was up here and gave a talk. I called that one From Fire to Photons. The basic premise was fire, fossil fuels, burning them, had served us well since caveman era, but that we were actually killing the earth from our own success. That the better alternative was taking power from the sun directly, that's photons, in its various forms, wind, solar, and that in fact the physics of taking renewable energy is so superior that in time, I said that fossil fuels will be pushed out of the market eventually. I said I didn't know how it would exactly go down or when, but I said, in conclusion, we will find out. So here I am a year and a half later, and this is essentially a follow-up to find out what's going on. Now, if you're going to do some sort of research, what do they tell you when you're an investigative reporter? What does he say? Follow the money. Well, we're doing energy, so I'm going to follow the physics. Find out what is spin and what is real. Let's start with something easy. Clean coal. Now, I'll read you a little, I got to put on the glasses to read. Robert Murray, coal baron, CEO of Murray Energy down in West Virginia. This is a quote. Carbon capture and sequestration does not work. Carbon capture is a pseudonym for no coal. Now, in case you think he's like some born-again environmentalist, he was speaking to cohorts of coal executives. His point is not that we shouldn't do carbon sequestration. He knows it can't work. So if the world is gonna require us to go out there and sequester this carbon dioxide, it really means no coal, because it's too darn expensive. Why does it give you an example? Down in Mississippi, let's see if I remember exactly where. It doesn't matter. The point is you got a coal plant, strip mine, right next door. No labor unions, cheapest place on earth to produce coal-powered energy, right? So that the government decided, okay, we'll get together, we'll throw some federal money at it, we'll do this sequestration thing. It'll all work out. And they got this little bit of state money, and of course the ratepayers are on the hook for the difference, right? Well, they spent $7.5 billion, which is 4.5 more than they anticipated. It was 4 years delayed, and about 6 months ago, they threw in the towel. They said, it's never going to work. And now they're burning natural gas at that very place. Now, why did this fail? It's basic physics. To manipulate fire, to do anything with it other than just burn it, takes energy. You have to, baffle you have to separate smoke, you have to do all these things, and then to pull the carbon dioxide out only. This is a real tricky thing. And When the bottom line was reached, it takes 25% of the energy, of the electricity that the coal creates to run the sequestration. So you can't possibly make money if you, I mean, regular coal plants are not cost efficient, to be quite frankly. They're already higher than wind and solar and natural gas. So where did they possibly think this would work? And yet that topic, that word, clean coal, gets thrown out there. And that's spin. That's totally spin. There's no such thing, never has been, never will be. It's dead, dead, dead. Not coming back. Doesn't matter who's the president, doesn't matter anywhere. The physics don't add up. Let's look at nuclear, which is not fossil fuel, and it doesn't have an emission, but it's the same principle that you have this enormous heat, and you're trying to manipulate and keep it from melting down, really. So you have all this Rube Goldberg apparatus of pipes and this and that and tower chambers and cooling chambers and that needs all this water. You know what one of the biggest problems of trying to create these things, the atomic energy, new ones, they can't find any labor. These welds, every single weld has to be done by hand. There's no robot that can go in there. This is all custom done, bespoke, if you will. So, and in one bad welding joint could, cause a meltdown, essentially. So the cost on nuclear has just gone absolutely through the roof. Everyone is designed differently. There's no scale, therefore. That being the case, for instance, Duke Power, which had been working for years to create a big nuclear plant that would take care of the whole Southeast and all this stuff, they threw in the towel. Now they're investing strictly in wind and solar. In Florida, for instance, they decided to put huge solar farms down there. There is only one current nuclear power plant still under development, and that's in Georgia, a place called Vogtle, I believe it is. The only reason that is proceeding is that the ratepayers are on the hook for it. This is a monopoly situation. Not every place is like this. Absolutely no other utility would dream of doing this because it would be a total disaster to their bottom line and their investors would go insane. But here it's a boondoggle, and so they're doing it. Until somebody, let's say a president, would put his foot down and say, no, this is stupid, we got to end this. But ultimately the physics will win out and it will get canceled, I guarantee you. Now, the one area of fossil fuels, I would be remiss if I didn't mention that natural gas is a very cost-effective in the U.S. We have such incredibly smart oil and gas industry. I got to tell you, I don't want to be a knee-jerk person and say these people are all idiots. They're not. These are smart people. The things that they have developed, I don't know if you realize, but the U.S. is the largest oil and gas producer in the world. And it's because these folks have figured out how to drill sideways, drill with multiple drill bits in the same hole, all sorts of things they've come up with. Fracking is one part of that. I got to tell you, the rest of the world's not so keen on fracking. They love our prices of natural gas, so we're liquefying it, sending it on a boat to them. Natural gas exports are going like that. Now, what's the value? Why is natural gas working? Now we're getting, the physics there works a little better. Basically, every plant, the motor is the same. It's basically a jet engine strapped down, and it burns really efficiently. The engines that they created to make jet travel cheaper and cheaper are essentially the same things that's being used in natural gas plants. The other thing is natural gas, you can turn it on and off. It only takes about depending on the situation, 10 minutes, maybe 20 minutes to get from cool to steam again. Coal plant takes 2 weeks or 2 days. Nuclear, forget about it, it takes 2 weeks. They only turn it off in an emergency like with Harvey, the hurricane. So, the problem with natural gas, of course, is methane. It is the one exhaust that comes out of it. It's a rather powerful greenhouse gas. It doesn't stay in the atmosphere forever. It does degrade. It goes away. However, it's much more of an insulating blanket than even carbon dioxide. And the whole issue, what's causing the heat and all this, is essentially we are creating a more dense atmosphere with gases. And it's the natural heat that's, every day of the Earth's life, it radiates heat out. But if you have an insulating blanket, it's warming things up, warming the oceans up. Oceans get warm, humid, hurricanes. There's always been hurricanes, but if you up the energy stored in the water, you're going to get a bigger hurricane. It's just simple physics. It's not like you can do something about it unless you do it at the source. So, I wasn't going to get too much into real physics. I promised my wife I wouldn't. But there is actually a super interesting thing that's being done down in Texas about natural gas. And it actually came out of clean coal monies that was done on research. It wasn't applicable to coal, but a guy named Alum came up with something called the Alum Cycle. And what it amounts to is, well, let's take a quick thought. Do you understand how electricity is made? You basically take a carbon source, you light it, you have a kettle of water, create steam. The steam is what you're looking for. The steam is like a muscle, and it turns a blade, a turbine blade, and you have coils of, and it creates this electron. They start to shed off of the coils electromagnetically. And it goes in the wire, and there's your electricity, lighting up the lights. Now, you use a lot of water to do this. So he came up with this idea, Alum came up with this idea that instead of just burning air, let's take pure oxygen. Let's light the natural gas and see what happens. Well, it burns the natural gas so hot that the only thing that comes out is carbon dioxide, and it comes out as it's so hot it's like a plasma. It's almost like a liquid, like steam. So they actually use it rather than heating water up, and it turns the turbine. When it gets cooled down or whatever, the point is that you have it in a pipe, it's contained, it's not an exhaust into the air. I mention this, in about a year we'll know whether this really works or not. But think about this. If you had pure carbon dioxide, what are you going to do with it, right? Now that sounds awful, right? But here's a thought. If you were able to create hydrogen, you mix it with it, now you have synthetic gas. You don't need to make oil anymore. How would you get hydrogen? This is interesting. Here's where we're getting to renewable energy again. The big thing that they want to do with renewable energy is some way to store when you have excess solar or excess wind, when it's not marketable. In the middle of the night, the windmill's going like this. There's no market for it. They oftentimes have to shut them down, like in Texas. They actually have to shut them down because there's no... What if they took that electricity and a simple process called electrolysis You shoot water, separates the hydrogen and the oxygen. What are you going to do with that oxygen? Well, you feed it to the natural gas, right? What we were just talking about. And then you take the hydrogen and the leftover, the carbon dioxide, you put that together, now you have this synthetic fuel. It would be a fantastic way to economically make electrolysis viable. Right now, it's just simply too expensive. I mean, why do it? Just make more electricity, right? But if you have a really fundamental use, because once you have hydrogen, you can do almost anything. You can fly planes with it. You can, all the things that you can't do with like a solar panel because it's too, it's not dense enough in energy. Hydrogen takes care of all those problems. And there's no, you burn it, there's no exhaust other than water, basically. All right, now let's get into the meat of things. How are things with solar power? You probably hear that it's getting better and better. Let me give you an idea. Our much maligned President Obama, when he started a Sunshot program back in 2010, he helped, well, not he personally, but the Department of Energy, they threw some money out to various solar research efforts. One of them was what they call thin film. That company had a colossal death. And everybody was saying, oh, this was the worst idea, Obama, you're an idiot. Well, Sunshot had numerous successes that, you know, don't get any press. But now let's look at at that time, they set the goal for utility-grade solar panels, which at that time was at 28 cents a kilowatt. They said, well, if we could get it down to 6 cents, then it would be equal to coal, it would be equal to natural gas. That'd be fantastic. I think we could do it by 2020. Well, this year, they're below, in Texas, all through the Midwest, from Texas to Wisconsin, they beat that price. It may not be doable in certain areas that aren't a whole lot of wind, but I'm telling you, in the vast stretches of America, the plain states, we're talking maybe 80, well, 3/4 of the country easily beats that. Now, we're not talking about like the solar panels here, frankly. When somebody out there, if you're talking to somebody at a cocktail party and they say, oh, I hear solar's really expensive. Well, if you're talking about on a roof, it is, quite frankly. I mean, think about it. The solar panel makes up a tiny part of the cost. You got to get, Joe out there with his ladder. It gets expensive. You got to do permits, all these things. These guys were coming in here and right and left. That's not the way it is in utility grade. The reason solar works is real simple physics. You got a free product, number one. You're starting with that. You have a very simple material, silicon. The frames and the structural stuff is minor. This is basic steel. Then you create them by the thousands and the millions, frankly. And when you make these utility grades, we're talking about, acres of these things. And a truck goes along and puts the struts in the ground, droop, 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 droop. It's no it's like apples and oranges. So, and then there's the convergence of technologies that happen. You probably have heard about drones, right? And you're waiting to get your first package from Amazon with their drone. Drones are out there in the solar field, maintaining the panels, checking for any errors, anything like that. That's their real use. You have a windmill, a wind turbine, 100 meters up in the air. Tommy doesn't go walking up the ladder anymore. The drone does it. You need service, all those feet up. The drone is able to take readings and figure out if it needs to shoot oil here, do this there, that there. This is what is allowing real advances, not just like marginal percent or two. Let me give you an idea on wind. Offshore in the North Sea, in the UK, just a week ago, I think, they had their most recent auction. What that is it's basically a number the government will guarantee that they'll make. It's like a floor. So 2 years ago, that auction, 119 pounds per megawatt hour, I think it was. Point is that this year, 2 years later, it's 57. Now, that's 2 years. This is about these learning curves. This is about scale. They're producing these now at a fantastic number. And they're coming to America. The very companies that are doing this, I can't resist this. Dong, that's Dutch, oil and natural gas, which no longer is in that business. They are now the world's largest offshore windmill company. They're going to make a huge windmill yard outside of British Columbia. They're going to do a very big one here on the East Coast. State Oil, which is the Norwegian oil company, they are moving away from, slowly, but moving away from oil and putting all their eggs in the renewable basket. They just bought the license to do the big field off of New York. In 5 years, we're going to be marveling at the size of these things. By that time, they'll be, right now they've gone from 8 to 9 megawatt towers. They'll be up at 10 or 12 by then. And so the prices that they're able to guarantee are just dropping like a stone. It will, well, I'll give you an example. In England, where this was just a week ago, mind you. So the big brouhaha over there is that for years now they've been planning this Hinkley atomic energy plant. An enormous thing that they were, and the Chinese are involved, the French are involved. Everybody who's still in this game of nuclear wants in on it, and for geopolitical reasons, you know, the English government wanted to play nice with all these people and say, yeah. Well, now, of course, the reality is, if the windmill is going to guarantee 57 pounds, Hinkley's already locked in at 92. And that's the best possible case. So do you want to be on the hook for nuclear that has a history of overshooting its actual costs, or do you want to lock in a technology that proves every year to go lower? I mean, it's a no-brainer, and yet politics may get, who knows? I don't have an answer on that one. So the wind power, the reason it's working, it's a young business still. Innovations are coming mile a minute. GE, which makes the natural gas engine I was talking about, well, they're huge in wind turbines. Just like 2 weeks ago, or maybe a week ago, they announced that they're bringing out a new generation. And in fact, at the time when I spoke last, they had just gotten to 3.6 megawatts for an onshore turbine. This week, they've announced 4.8. Now, a 30% increase, that's significant. Because all these numbers that I'm talking about, where wind is lower than coal or natural gas, I mean, in Texas, it's way lower. Now you're going to improve it 30%? And probably even the most important part about this is that because these are extra tall, even though, let's say a place like here in New York, upstate New York, it's moderately windy. It's not what I would call the plains, but these are going to be viable there. It's going to be viable in the entire East Coast. And right now, the current windmills are, you know, you got to get them like right on a hill, right in a certain place. Now they're going to become widespread. And that will make a huge difference, because the only reason these coal plants are still going is that nobody's able to push them out of the market because the money's already sunk, right? It's already there. You might as well keep running it. Well, when new wind costs less than just maintaining a current coal plant, well, it's a no-brainer again. And that's where we're at. We're coming to that point so rapidly. I mean, as far as new, forget about it. There's not a single new coal plant on the last one, in fact, that was on the planning stage in Kansas. They just announced, well, after 10 years and $93 million spent planning it, they came to their senses and said, we're going to buy some windmills. I mean, how could you not? If you're an investor, how could you possibly let them not do that? So let me get into transport, because this is also a big deal. Now that we're getting much less emissions in the power sector, by comparison, even though auto emissions are slightly going down, now they're the biggest source, comparatively, of emissions. Now this gets interesting, because a lot of things converge on this. A year and a half ago, I had talked about Tesla and this and that and the different cars. A lot of new cars are coming out with electric. There's a lot of lower cost possibilities. And I'll get into Tesla a little bit more later, but the real action, well, talking about physics and clean coal, have you ever heard that expression, clean diesel? You know, the Volkswagen, that was one of their taglines, clean diesel. Well, I got news for you. Same deal. There's no such thing. Never was. It was a lie all the time. And when this first came out and we heard about a defeat device, it sounded like, you know, run-of-the-mill corporate malfeasance, somebody didn't do what they were supposed to, blah, blah, blah. No. It's the physics can't work. If you're going to manipulate these emissions, you're going to do this to it and that to it, you got to baffle it here and there. It all takes power. Where does that power come from? It comes from the diesel fuel. It's the only source there, right? So the way they got around it for years, and this is really, talk about criminal, and I don't know who's the biggest criminal here, but the testing agencies in Europe and the companies, one or the other, gave in, somehow they bullied them into this idea. The testing, put aside defeat device for a minute. Even though cars without defeat devices, the testing is only meant to test when the engine is cool, or just starting, in other words. In real use, because now they've gone back and tested all the diesels out in Europe, not a single one of them meet the emission standards. And we're talking not a little bit, 30 times the amount of nitrous oxide that they're supposed to have. And what it boils down to, you can't have no emissions and good mileage and have a good auto. You got to do one or the other. If you are going to do both, emissions control and good mileage, you have to govern it down to where, oh, maybe you have a top speed of 45, 50 miles an hour, and it takes about 3 minutes to get to that speed. You know, this would be a piece of junk, and nobody would buy it. And that's precisely why industry and the government, in cahoots, I think, said, well, we'll just pretend. And we'll have a big industry, and we'll have lots of billions of dollars, and maybe it'll all go away. I got news for you. China and India are not so stupid. China is the biggest auto market in the world. I don't know if you realize that. By volume, almost as many as the US and Europe combined. How much oil does China produce? Not very much, very, very little. So if I'm the leader of China and I'm looking at this, I'm saying, wait a minute, I'm going to make all these cars and burn all this gas and import all this oil so that you can make money? That's not going to happen. India and China independently have both determined that they will no longer have internal combustion engines. The date is still being set, but 2030 has been thrown out there in India, and China's probably going to match it. When this happens, and when this becomes the official policy, by the way, China already requires 8% this coming year of any foreign auto company of sales in their country have to be electric in some way, shape, or form. It's a complicated formula, but the point is it goes up every year, too. In 4 years, it'll be 12%, and that sort of thing. And in 2030, it's gone. That talk about inevitability. If the biggest market on earth is shut out, trust me when I tell you, the investors, I mean, nobody's stupid. They're going to start fleeing these companies if they don't make the change. So what do you hear now? Well, Volkswagen says, oh yeah, we're going to be all electric any day now. They really mean in 2022. But Volvo says in a year they're going to be, everything will have a cord. Jaguar and Land Rover, same. Now, Volvo is owned by a Chinese company. Land Rover and Jaguar owned by an Indian company. So the world is taking note of this stuff. So what does big oil do? Actually, in the transport sector, you've probably heard about driverless cars, right? That's coming very soon. There's a reason why that's going to really work well with electric. The cost to run an electric car is way cheaper per mile once you've purchased it. Right now, it's a little higher on purchase than a comparable internal combustion engine, but that price is dropping rapidly. They predict that in 2 years, the purchase price will have parity. The running it price, the fuel, the maintenance, I mean, think about it. There's 20 moving parts in an electric car and about 2,000 in a typical internal combustion engine car. The repair people are going out of their minds with this thought. Dealers, for the longest time, were reluctant to even hear about electric cars from their franchise people, their GMs and everything, because they knew that their big money is made on repairs. Well, if you have car sharing, and then the next version of that is driverless cars, you call your car, hey, get me. Why would it be internal combustion? If it's cheaper to run it per mile with electric, why wouldn't you? Of course you would. Because you're going to be running this thing for 1 million miles. And I mean literally 1 million miles. The idea of 100,000 miles on a car will be laughable. There's nothing to break down. The brakes don't even wear out because it's regenerative braking. No, the batteries, well, you can replace batteries eventually, of course, over 1 million miles, but the bottom line is it's much, much cheaper. I might as well give kudos to Elon Musk. The genius of Elon Musk is not that he came up with electric cars, I mean, that was other people, but the marketing. This idea, instead of going for like the, well, he understood if you want to capture the attention, you put out a muscle car. You do a sports car. So his first car was a Roadster. And then the Model S. The Model S, you realize this thing wipes the floor with Porsches and everything like that. Not a single gas car can beat this car to a quarter mile or anything like that. The handling, everything about it, because the batteries keep the weight low, so it's an ultimate sports car. So all your, your swells that have some money, they had to have this car. Now, of course, now that Tesla's worth $58 billion, the company, now, yeah, they're going for a mass market. The Model 3 is coming out. It's getting great reviews, and I would love to drive it at some point, but you can't even get it. It's not even, it's only going out to the people who signed up for it. 450,000 people put up $1,000 just to be in line to buy this car. You can't buy it unless you're online. That's how, believe me, this is going to shake things up. The real story, though, on electric is going to be the plebeian delivery truck, the vans, the pickup trucks. Think about it. That's where the real meat is. I drive to work, I come back, I put it in the garage. I don't take my truck out. It's logical. You're going to charge it, right? I don't drive it on the freeway to LA. If you're DHL, you're doing 50 to 100 miles in a day on delivery. That would be hard to do. The likelihood that they go over 50, 60 miles is pretty unusual because it's all local deliveries, right? Nobody's going to next state. That's a whole different class of vehicle. So these trucks go in and they sit there at night when everybody's closed, plug them in. It is so compelling that DHL, which is German, Deutsch is the D, they were haranguing Volkswagen, who had been supplying them for years. Give us electric, let's do it. Volkswagen said, this is 2 years ago, Volkswagen, we're not interested. They designed one on their own. It was so well received that now Ford of Europe is going to produce them worldwide. Well, for sale in Europe. All it is a box on wheels with a battery and some computing power. All these electric cars are basically computers on wheels and some batteries. And when you think about it, for instance, when something needs to be improved on one of these electric cars, Tesla just downloads the software to you. You don't have to buy a new car. They just improve it. It makes perfectly good sense, right? And yet, you don't see anybody else doing it. So, what are some of the global impacts? Well, you know that adage about adapt or die, right? Well, diesel is dead, dead, dead. Coal's dead, dead, dead. Internal combustion engine in general, a few years from now, maybe 10 most, is dead. So how are these folks going to adapt, and how are they adapting? I mentioned Dong, which was very, very advanced thinking way back. State Oil. Shell in Europe, a Dutch Royal Shell, puts a lot of money now. You wouldn't even know it because they use a different name, but they put a lot of money into solar and biofuel. Now, could more things be done? Yeah, but let's compare it to our groups here in America. Whew. Chevron, forget about it. That company is so retro. They're the ones who have, along with Koch brothers and stuff like that, have funded climate denial, that sort of thing. Tillerson's Exxon, when he was there, they diversified all the way from oil to oil and natural gas. That's a joke, by the way. They do not want to change because it's so profitable and so nice. Their way of life, everything about it. They don't want to hear about change. They don't want that change. Petrostates like Russia, Forget it. This is basically a oil mafia with nukes. The last thing they're interested in is electric cars or anything like that. You will never see it there. They'll go down kicking and screaming. What about a place like Saudi Arabia? Here's something interesting. So the young guy, the young heir, how did he get to become the heir apparent? He's an educated guy in the West, drives all the electric car, knows all this stuff, right? Basically, he won the argument that it's inevitable that oil is going to decrease in value. It's inevitable. I want to, meaning he, I want Saudi Arabia to do an IPO. We'll sell our company. Arab Oil, or Aramco, whatever they call it. And they're talking about $1 trillion value. Well, they better hurry. This guy had to basically threaten to rub people out to get to where he is, and because he wants to cash in. And he's smart. He's absolutely right. 2 years from now, it's going to be half the value. I mean, why would an investor? Investors buy the future. So it's a no-brainer. So all those states, those oil dictatorships in the Middle East, you know, everybody who's entrenched in power owes it to having been in the oil business, so to speak. So that's going to be a tough evolution. And frankly, they don't have any grassroots to put pressure on them. So that's going to be an interesting thing. Frankly, I think they're just going to tough it out. They have the cheapest oil going, so why not? They'll just peter out with the market, and that's that. That brings us to America. And I have some thoughts about where we're at and what we're doing and where it's going. I sort of alluded to Koch brothers and people like Chevron that pay, you know. Well, how about the last election cycle? Once upon a time, not very long ago, certainly when the first Clinton was running, oil and fossil fuel industry, oil industry, about 60% Republican, 40% Democrat, donations. This last election cycle, 98% to Republicans. I'd like to see that Democrat that they gave money to. He's probably deep in the oil company. They have put all their eggs in this idea that they can delay, stall, and perhaps even thwart the economy if they just do a sales pitch good enough. You know, they basically, and you could hear it in the way they talk, by the way, and when I say they, I mean the whole right-wing radio and all this stuff. They have basically convinced people that fossil fuels mean freedom and prosperity. Everything about it means it's the anti-nanny state. All those people on the left, they want they want to make you have restrictions. They want to have you have rules. All these things like that that's going to ruin your life. Your life is based on freedom, prosperity. Well, this is about us now as people, humanists, and how do we go to a cocktail party and talk about this? If you meet a guy that's saying, no, climate change, I don't want all those rules. You cannot win that argument with your argument. You cannot come to them with, we need it for saving the earth, we need it for lessening emissions, we need it for global warming, climate change. That cannot work. That reinforces their idea that you're out to take away their freedom and prosperity. You want to win that argument? You stand and deliver that renewable energy means freedom and prosperity. And it's absolutely true. That's the kicker. If instead of sending billions of dollars to Saudi Arabia, what if we send it to Iowa? Let them charge the cars instead of filling them up with Saudi oil. Would that be so bad? Would Texas be worse if they had lots more money? I think they could live with that argument. You gotta meet people where they are, and they have been brainwashed that somehow climate change means they're going to be poorer, that they're going to be restricted, that they won't have the life that their dad had. You got to flip that. You got to say everything about clean living with clean energy, clean cars means more for all. It is truly something that would make America great again. And I mean that sincerely. So, I don't really have a whole lot more to add. I mean, that's really the essence of my thought today, is that if you want to do something as a humanist, make that argument, and I want to hear you say it. Freedom and prosperity. Sink it into your brain. Renewable energy means freedom and prosperity. Get that argument out there at wherever you go. People's heads will flip around. I swear to God. Their heads will go, you're speaking my language? I think I'll draw an end to it there and just open it up for questions.